In question number 6, a uniform disk moving on a frictionless horizontal table collides elastically with another identical stationary disk as shown. Fraction of total kinetic energy transferred to stationary disk during collision is. Suppose initial velocity is u, and at the time of collision the situation is something like this. Suppose this is the disk and this is the line of collision. So if I see this is 2r, this is r, this angle is theta, then sine theta in this triangle can be written as perpendicular r divided by 2r. So the value of theta comes out to be 30 degree. So if I take the component of u in this direction, so this disk has velocity in this direction is u cos 30 degree or u root 3 by 2. And this disk is at rest. Since both the disks are of same mass, so after collision, first disk will be at rest and the second disk will move in this direction with a velocity u root 3 by 2. That is the exchange of velocity. So if I write the kinetic energy of the stationary disk after collision, that can be written as half into m u root 3 by 2 whole square, and the initial kinetic energy of this disk is equal to half m u square. So if I solve this, it comes out to be 3 by 4. So option 2 is the correct answer. Let's move to question number 7. In question number 7, a meter stick AB is held vertical with one end hinge on the floor and is then allowed to fall. Find the acceleration of other end B of a stick when it is about to hit the ground. So we have to find out what is the acceleration of this end B when it is about to hit the ground. So in order to find the acceleration, first of all, let's find out its centripetal acceleration. So at this moment, let this angular velocity is omega. So from the principle of conservation of mechanical energy, I can say that mg into L by 2, that is the laws of potential energy, is equal to gain in kinetic energy, half I, that is ml square by 3 into omega square. So from here, if I solve for omega square L, that comes out to be 3g. Now, so if I find out what is the tangential acceleration at this moment, so in order to have this, I am writing the torque equation. So mg into L by 2 is equal to I into alpha, that is ml square by 3 into alpha. So from here, the value of alpha L comes out to be 3g by 2, that is equal to tangential acceleration. So the net acceleration is equal to under root of AC square, that is 3g whole square, plus AT square, that is 3g by 2 whole square. So if I solve this, it comes out to be 3g by 2 into root 5. So option 2 is the correct answer. Let's move to question number 8. In question number 8, a steady current I0 goes through a wire loop PQR having the shape of right angle triangle as shown. Magnetic field at point P. So the magnetic field at this point due to this current carrying wire and due to this current carrying wire is 0, as the current carrying wire passes through this point. Now I have to find out what is the magnetic field due to this current carrying wire at this point P. So in order to find this, let I drop a perpendicular from point P to this wire and let this distance is d. Then d is equal to d sine 37 degree. Sine 37 degrees 3 by 5. So it is equal to 4.8 meter. Now these endpoints makes an angle of, here it is 53 degree and this angle is 37 degree. So if I write the magnetic field at point P due to this current carrying wire, then it can be written as mu naught I naught divided by 4 pi d, where the value of d is this, into sine theta 1, that is 37 degree, plus sine theta 2, that is sine 53 degree. So if I substitute the value of d and solve this, it comes out to be 7 mu naught I naught divided by 96 pi. So option 3 is the correct answer. Let's move to question number 9. In question number 9, A uniform rod of length L and mass 6m lies at rest on a frictionless horizontal table. A small particle of mass m moving with speed v0 collides with the rod perpendicularly at one end and it comes to rest after collision. The coefficient of restitution is. So let this is a uniform rod of length L and mass 6m. And another point mass is moving with velocity v0 and it collides at one of the end. Its mass is m. So just after collision, this mass m comes to rest and it moves with velocity v and let it rotate with angular velocity omega. So if I write the equation of Newton's law of collision, then the value of E is equal to minus v2 minus v1 divided by u2 minus u1. So the velocity of this point after collision will be v plus omega L by 2. Velocity of first particle after collision is 0 divided by u2. Velocity of second particle before collision is 0 and the velocity of first particle before collision is 0. So this comes out to be v plus omega L by 2 divided by v. Now we have to find out what is the value of omega and what is the value of v. So from the principle of conservation of linear momentum, I can say that m into v0 is equal to 6m into v. So from here the value of v comes out to be v0 by 6. And from the principle of conservation of angular momentum, I can write m v0 into L by 2 is equal to I, that is ml square by 12. So m is 6m, L square by 12 into omega. So from here the value of omega on solving comes out to be v0 by L. So on substituting the value of v and omega, it comes out to be v0 by 6 plus v0 by 2 divided by v0. So on further solving, it comes out to be 2 by 3. So option 3 is correct. Let's move to question number 10. In question number 10, a satellite is revolving around Earth in a circular orbit of height h is equal to r from Earth's surface, where r is the radius of Earth. If the satellite is stopped suddenly and allowed to fall freely, then the speed with which it hits the surface of the Earth is. So, since the motion of the satellite is only under the conservative gravitational force, so I can write the gain in kinetic energy is equal to loss in potential energy. So half into m into v square is equal to loss in potential energy. So that I can write minus g capital M small m by 2r plus g capital M small m by r. Initial separation from the center of Earth is 2r and final it is r. So if I solve this, the value of v square comes out to be gm by r. So if I multiply and divide by capital R, then gm by r square is g, so it can be written as g into r. So from here the value of g comes out to be under root gr. So option 1 is the correct answer. Let's move to question number 11.